Hello, everybody, and welcome to Discovery Days 2020. My name is Corbin Clausen, and I'm from Meade County.
I'm Preston Dunn. I'm from Stafford County.
And I'm Blakely Aldridge, and I'm from Wallace County.
Today, we're going to be telling you about the 4-H Science of Ag Challenge. So I want to start off by showing you a promo video about what we're going to be talking about today. So for all of our information that we started with today, or we're going to be telling you about, will all be on the Kansas 4-H website. And to find this, you'll just go type in the kansas4h.org, and then under projects, the drop-down menu, you can find science, engineering, and technology. And you'll click on the Science of Agriculture Challenge. And then this will have all the information that we're going to be telling you. So if you have any questions or want to learn more about it, this is where you'll go to find more about it. So I'll just start off by showing you this video, and it'll kind of tell you about what we're going to be showing you today.
The 4-H Science of Ag Challenge is probably the most real-world life application experience that we're providing right now. To be honest, I'm really excited about where this program is headed and the skills that it's giving our young people. The ability to think on their feet, think critically, real-world, agriculturally related issues. And we're not just asking them to research the problem, we're asking them to solve it. And that's some really high-level thinking for our young people.
So many of our challenges for the future are not things that just one person's going to be able to say, oh, this is what you need to do, but rather it's an opportunity for us to gather together, view a problem, and view solutions from multiple perspectives, and then come together and say, what is the course of action that we need to move forward in order to benefit our community? It's those kinds of skills that I think are necessary and really critical for the future of Kansas economy, and in particular, the future of agriculture.
I think it's a fantastic opportunity to learn and grow, and I think as they learn more about a particular topic, I think it would be highly likely that might change the course of what they want to pursue and follow, because they know a lot more about a particular topic, and I could see where it would be very likely to change their direction of study because it changes their interests.
So that'll kind of tell you a little bit about what we're going to be talking about, the Science of Ag Challenge today. So we'll just go ahead and go through a short slideshow real quick about more in-depth information about how you can get your, or about what is the Science of Ag Challenge and how you can get involved and build your teams. So the 4-H Science of Ag Challenge 2020. So what is the Science of Ag Challenge? The Science of Ag Challenge offers a hands-on learning experience to inspire the next generation of agricultural leaders. Your team will work with volunteer coaches and mentors to create projects and build solutions. As a part of the challenge learning process, you'll learn 21st century skills such as critical thinking, team building, decision-making, communications, and more.
So what will you do? You're going to solve a problem or issue in agriculture using your community, or maybe it's statewide. You're going to work with friends to meet new people, learn how to use science and engineering practices, develop skills you'll use in school and future careers, and you'll compete to win a scholarship.
About teams. You can form a team or join one in your county. Teams include 3 to 5 youth in grades 6 through 12. Each September, teams present their solutions at a preliminary event to prepare for the state competition at K-State in November. Each member of the top 3 teams will receive a scholarship to use at the university, college, or trade school of their choice. One team can win the Community Engagement Award for sharing the story of their project through community presentations, social, and media print.
So what will teams do? They'll choose a topic to explore in agriculture, use the 8 science and engineering practices to guide your project, work with volunteer coaches and mentors to create and complete the project, learn from agriculture experts in your community, and learn about agriculture careers locally and statewide.
Do youth do these challenges alone, or this challenge alone? No, youth can have a coach and mentor to help them guide and help them with their project. The role of the coach is to inspire the team and help them get excited about the science of agriculture. Coaches give team guidance and provide structure, encouragement, and most of all, a fun experience. They meet regularly with the team and guide them into developing goals and a timeline. The coach serves as the facilitator to help the team compete its work and improve the way the team works together. Coaches will guide the process while the youth control the content.
What do team coaches do? Register the team online, organize and attend team meetings, guide the project learning process, make sure the timeline is followed and deadlines are met, work with the team to identify a mentor or mentors, chaperone the team at the state event.
So what do mentors do? A mentor is any person who works with a team in his or her area of expertise for at least one team meeting, but the most effective mentor relationship is one that continues over time. Mentors help expose the team members to potential careers in addition to helping them learn skills necessary to complete the SOAR challenge. The most important quality for a mentor is someone who enjoys working with young people and wants them to learn.
So what do team mentors do? They provide experience in a work or field of work, offer project ideas, teach and inspire, and give feedback. They listen and guide and encourage youth.
So now that you kind of know what this whole Science of Ag challenge is, all that information that we just went over is all on this the Kansas 4-H website, like I said earlier, and you can kind of scroll down and then go to the information for youth and parents, and it'll give you a lot of information on this. But today we're going to actually give you an example. So our team, actually, we had another kid on our team, so you can have up to, I think, 4 people on your team. So we actually entered in the Science of Ag Challenge last year. And so,
I think you can actually have 5, Corbin.
Or maybe you can have 5 people on your team. But we entered last year in the Science of Ag Challenge. And so we just wanted to bring awareness to it so that more people can get involved and have fun with this event. So it's really fun, and it's a pretty easy way to get scholarships. So we're just going to go through our presentation so you can kind of have an idea of what this Science of Ag Challenge is all about. And so we'll just go ahead and present ours. So let's feed more beef. There is a genetic solution. Hi, my name is Corbin Clausen, and these are my team members, Blakely Aldridge, Preston, and Ian Dunn. Today, we're going to define the problem of feed efficiency in beef cattle, discuss how feed efficiency is measured, how that data is recorded and used, and define the impact that improving feed efficiency has, not only on the rancher's bottom line, but also the impact on the environment. So what is feed efficiency? The Lucky 7 Angus Ranch in Wyoming defines feed efficiency as the ability to either maintain or gain body weight on less feed than another animal in the same environment.
Feed efficiency. Researchers have been studying feed efficiency for nearly half a century. However, it has recently become a popular topic among cattle producers, seeking to grain more beef on less feed. This desire is to use less feed is fueled by higher feed prices and limited feed supplies due to drought, increasing utilization of grain for fuel, increasing world population causing a decrease in available acres for crop production, and increasing input costs for feed. The problem. Cattle convert 7 pounds of feed to 1 pound of gain. Swine convert 3.5 pounds of feed to 1 pound of gain, and poultry convert 2 pounds of feed to 1 pound of gain. Beef is more expensive to produce and more expensive protein for consumers to buy. Genetic improvements is slower because of the longer generational intervals. Traditionally have measured in animals' gain but not feed efficiency. You can't improve upon what you don't measure, and you can't tell by looking at the animal. Here is a picture that illustrates what improvements can be achieved through genetic selection. Chickens have been making dramatic feed conversions and muscling improvements over the years. Cattle have been making improvement too, since 1957, but they aren't as dramatic. The goal is to have the right data for beef that leads to the very best genetic selection in beef, so that similar improvements in feed conversions and muscling can be made. It's especially important to have the best data possible for beef because the generational interval is so much longer for cattle. Think about it. The time between a breeding decision and when the offspring is born is almost a year. It's a little more than a year before the offspring can be bred, and it's another 9 months before the offspring is born. You'll need another year of growth in the offspring to measure its growth and feed conversions. So it takes at least 4 years to see and analyze the results of specific genetic selection decisions. The same analysis can take less than a year in other species.
Our group interviewed Bob Prosser, owner of Bar T Bar Ranches in Arizona, which he runs about 1,200 females. He has been studying genetic feed efficiency for about 12 years and has been working specifically to breed feed efficiency into his herd. He was the first person we interviewed and helped explain to us what is being measured and what is being learned through this research topic. He told us about the illustrated example on this slide and where we could get this slide. These are two bulls that were almost the same. They were from the same herd, they're phenotypically similar, and if I was judging or comparing them, they're both deep-made and have muscular thickness, as well as they're structurally correct. They're only 22 pounds different in yearling weight. They both gained a little over 4 pounds a day, but looks can be deceiving. These bulls are not equal. The black bull ate 17 pounds of feed, and the red bull ate 42 pounds a day. Let that sink in. The black bull ate 17 pounds of feed, and the red bull ate 42 pounds of feed per day to gain the same amount of weight. When you consider that feed efficiency is 40% heritable, which means it can be bred into a herd within a few generations, it's a factor worth focusing on as a breeder. The significance of both financial cattle owner as well as natural resources. In this case, looking at the range of feed efficiency on these two bulls, if you had cows that converted the same as the black bull, you could run 112 cows on the same amount of grass that would only support 75 if you had the feed efficiency of the red bull. Over a year, the red bull eats 9,125 pounds more than the black bull. Let's put that into perspective. This feed truck holds 9,000 pounds when it's completely loaded.
So how do you measure feed efficiency? You begin by tracking how much each animal in a pen eats. This is done with an electronic identification tag in the animal's ear. These EID tags have the ability to record data individually for the animal throughout its life. The tags are synchronized with the scales in the feed bunks that measure each time the individual animal eats or drinks. An actual example of how this feed efficiency is measured is through the GrowSafe System, which my family has been utilizing for 9 years. Normally, cattle eat at a bunk, and it's difficult to tell if one calf is eating more than the calf beside it. With specialized systems like GrowSafe, the EID tags can be synchronized with the bunk to measure the intake of each calf on its individual basis. Our team interviewed Kevin Grossino, senior data analyst of GrowSafe Systems in Ontario, Canada. He explained to us in greater detail how the information is collected at the bunk and how they are trying to expand the database to create EPDs that will measure this genetic trait regardless of breed. The individual data is collected at each of the bunks or pods, which weighs the feed in the bunk. A scanner on the back side reads the EID and identifies which animal is at the bunk. When the animal is done eating, it weighs the feed to see how much the animal has eaten. The bunks are also designed so the cattle can't knock feed out of the bunk. These are the kind of systems that Preston's family has at their feedlot and seed stock bulls on.
With the importance of data collection systems, we are able to measure what cattle are individually eating. Without this system, how do we know exactly how much individual eats and gains? This is actual data from a study done in Scotland by the GrowSafe System. So you may notice it is in kilograms. But the point is that both daily gain and feed intake are measured to calculate feed efficiency. In this example, the circled dots illustrate the performance of two animals which grew at the same rate, 1.5 kilograms a day, but had a dry matter intake that differed from 7.6 kilograms to 9.1 kilograms, or a 19% difference in efficiency.
Many breeds have residual feed intake, or RFI EPDs, which measure feed efficiency. This EPD, or statistical calculation that predicts the performance of offspring based on the genetic history. This EPD is data that is available to cattlemen of any size to use selecting bulls and replacement females. Here is an example in the red circle. For data collection in an individual pen to be useful for breeding decisions, many ranchers need this data to be standardized. This is done by calculating residual feed intake. A positive number means the animal will eat more compared to the standard to gain a pound. A negative number means the animal will eat less and gain the same amount of weight. This chart was collected on a pen of yearling bulls at Seed Stock Plus, which is a marketing group which we belong to. What does this tell us? So the top bull here that has the negative 0.509 RFI, he's the most feed efficient bull in that pen. And the bull with a positive 5.05 is the least feed efficient bull in that pen. So they're having a dry matter intake of 10 pounds a day difference. So that's pretty big when you're calculating feed efficiency. So that's why it's such a big deal. So these are second generation feed efficient bulls, which that means their parents were bred for feed efficiency. And this pen on an average had a average dry matter intake of 26 pounds a day. So these three bulls in the pen are actually bulls my brother and I raised. This helps us get an understanding where our cattle stand compared to others. In this pen, there was a 7-pound spread in feed efficiency and an average dry matter intake of 28 pounds per day. These bulls were also second generation feed efficiency bulls, so you might notice that there's another bull in the pen with a negative 5 RFI, which is really good. RFI is used to calculate breed feed efficiency numbers like I talked about before. These are very easy for any cattle producer to use. Unlike the other two pens, these bulls aren't bred for feed efficiency. These bulls had a 6-pound spread in feed efficiency, which also means they had a large spread in feed efficiency. The most important takeaway is the average dry matter intake was 31.2 pounds a day. That's a 5-pound difference than the other pens I talked about earlier. 5 pounds a day times 30 pounds of dry matter, times 30 pounds equals 150 pounds of dry matter, which equates to over 300 pounds a day of actual feed. In a 50,000 head feed yard, 5 pounds a day, that's 250,000 pounds of feed, which costs about $11,875. That extra 28 loads on the feed truck, that would be an extra 28 loads on the feed truck we showed you earlier.
As cattle producers, each of our team members realizes the importance to the pocketbook of being able to select for feed efficiency. But after we started this research project, we did start wondering, how many other beef producers in Kansas are currently selecting for feed efficiency? These next 5 slides are from a survey that we conducted in cooperation with the Kansas Livestock Association. The KLA gave us the opportunity to pose these questions to Kansas beef producers on the KLA Facebook site. We first asked, are you a seed stock cattle producer or commercial cattle producer? 56.5% answered they're commercial, and 43.5% answered seed stock. When do you sell your calves? 26.1% said harvest, 39% said yearling, and 34% said weaning. When selecting breeding stock, do you currently select for feed efficiency? 52% answered yes, and 47% answered no. Do you currently collect feed efficiency data on the cattle you raise? 30% said yes, and 70% said no. Our last question we posed was to rate these 6 traits in order of importance to you when selecting breeding stock: feed efficiency, carcass traits, frame size, calving ease, average daily gain, and weaning weight. We discovered that calving ease was the most important to cattle producers when selecting breeding stock, and that feed efficiency was by far the least.
The impact. Reducing the feed intake of an animal, yet keeping their average daily gain the same, will benefit the rancher by having the animal eat less. As an animal requires less feed, a rancher is able to put more cattle on less acres of grass. In addition, an animal eating less feed will also impact the environment in a positive way by reducing the amount of methane gases released.
We interviewed Kevin Unger, former manager of Decatur County Feed Yard and currently with Lincoln County Feed Yard in Nebraska. He gave us this graph. This data was collected from 280,000 head at Decatur County Feed Yard over the course of 7 years. Out of all the things that affect profitability of a rancher, feed efficiency has the largest potential impact to the rancher's bottom line. They knew the background on these cattle prior to feeding them at the feed yard. Background meaning they knew genetic selection, feed, vaccinations, and breed. These cattle were anywhere from $550 to $1,175 more profitable per pen than cattle that they didn't have background on.
The carbon footprint. Improving feed efficiency can help reduce the carbon footprint cattle leave behind. An animal that eats less feed will not require as much land or water on which to produce its feed. An animal that eats less feed will also produce less manure. Finally, a decrease in feed intake will also result in a lower percentage of greenhouse gases produced. According to the Environmental Protection Agency, only 2.6% of all greenhouse gas emissions come from cattle. However, farmers and ranchers are always looking for ways to improve the environment because, after all, we are the original conservationists. We depend on the land and water available for our livelihood, so we are always looking for better ways to improve the environment.
In conclusion, selecting for feed efficiency in beef cattle will help the producer save money, use fewer natural resources, and leave a smaller carbon footprint.
That concludes our presentation.
So for the Science of Ag Challenge, you could do anything to do with agriculture. It doesn't have to be like ours was with cattle. Yours can be with crops or anything related to ag, really. There's not a whole lot that you can't really do. But we'll just go through the rest of these slides. for more information.
So, some of these important dates. Unfortunately, the registration is kind of closed for this year. So, like January to March was kind of for teams to identify their projects and really just kind of figure out what they wanted to do. And then they extended the deadline to April 30th. And that was the final team registration deadline. And September 18th is the preliminaries for the Ag Innovators Day at Kansas State Fair. So if you really want to get like a better idea about what's going on and you're at the state fair on September 18th, I encourage you to stop in, maybe see what's going on, and just get a better idea. So if you wanted to do it next year, you just have a better idea of what's going on. And on November 14th, that is the actual competition. So down here, we left our contact information. And so you can either reach Corbin, myself, Blakely. Anissa Jepson is the person who is in charge of this contest. So any one of us could probably answer your questions. If not, we'll direct it to Anissa. So, and then again, if you want more information, go to kansas4h.org.
Yeah.
And
So,
I
yeah,
think that's about it. Anybody else to add?
I'll go back one more time to the how you get to all this information about the Science of Ag Challenge. So you can go to the Kansas 4-H website. You go to Projects, Science, Engineering, and Technology, and then the Science of Agriculture Challenge. And this will have literally all the information about this. Our slideshow, we just pulled it, all the information straight off from the Kansas 4-H website. So if you want to see something again or have any questions, it's all on here on the website. So
we should go back to our contact information just in case they want to see it again.
So here's our contact information. So if you have any questions, since this is recorded and you can't answer them in person, but yep, this concludes our presentation. So I hope you guys have a good rest of Discovery Days and go to many other classes. And I hope this helped you guys all out.